The next topic for us to investigate has to do with digital images, not surprisingly. Digital media comes in many forms, but images are by far the most commonly used format. When you find interesting images on the web, you can easily save these to your local device. This might be something that lots of people know, but there's probably going to be a few new aspects to this. On a desktop operating system, this is often done by right-clicking on an image in a web browser and saving it to some location on your local machine. Some sites will utilize various methods to prevent you from doing this, like Flickr does this. You should also be mindful of the license of the image that you are attempting to save to see what it's released under. Previously in this course, we learned about Creative Commons and copyright, and you should restrict your use of images to those that you know you have rights to. This can be implicitly stated by a Creative Commons license attached to that site, or you might be given permission by the owner of the images if they are copyrighted. There are also stock photo sites that will give you bulk access to a whole library of images for a certain fee. Shutterstock is a good example of that type of service, but there's lots of others. You can also get information about the images in most web browsers. Information about something is called metadata, or data about some other data. In Chrome and Firefox, you can view the metadata for an image by right-clicking on the image and then selecting Inspect Element. This will open up a new section in the browser that shows you the HTML and CSS for how the image is displayed, which we'll learn about later on in this class. You can learn the size of the image by hovering over the image tag in this pop-up and see the size for that image in pixels. We're going to learn more about CSS and HTML in future lessons. In Photoshop, there's also a number of ways to get metadata about your images. Most common is just to go up into the File menu and look for File Info, which is labeled very nicely, and use that. The data that tells a computer how to display an image can be stored in different ways. Each has its advantages and disadvantages, just like a lot of things. There are a number that you're going to need to know about for this class, and those are the PSD, JPEG, GIF, and PNG. We'll start out with Photoshop native format, which is the PSD file. This is a format that contains all of the layers and the fonts and all the bits and pieces that make up your image in a way that you can easily manipulate. Okay, so web browsers will not natively display this format, so when it's used for creating your images and not placing them on the web. If you want to put your image on the web, you need to export it in a format that the browser will actually be able to know how to display, and that's our other three that we'll talk about here in a minute. You can kind of think about the PSD file as, your desk, right? So you collect all the different parts and pieces of a project and you lay them out on your desk, images and books and scraps of paper and so forth. And then you combine all of those to make a final project that the rest of the world can see. But if you want to go back and make a change to that final product, it's not very final if you're going back and changing it, I guess, you would go back to your desk and all the stuff is still there to be able to, make changes to those parts. That's what the PSD file is. It's your working copy of your image. It's where you can easily manipulate the various parts of it and then save that out to something that you can put on the web. So, the PSD format is also known as what's called a lossless format, due to the fact that it stores all of the information about the image. Okay, so every layer, everything, even stuff that you can't necessarily see on the screen, there's still information stored there about that. And that means the PSD files are usually significantly larger than the same size image in the other formats that we're going to look at here next. The JPEG format was originally developed in the 1980s, and it's really good for photographs and complex patterns and so forth, but it's not so good for images that have large flat areas of color. Sometimes you'll see some blockiness, kind of like in digital cable or satellite TV or something like that. You see the same kind of thing in JPEG images. So things like logos and buttons and stuff like that are usually not JPEGs. JPEG is what's called a lossy format, in the opposite of the lossless format that we had with the PSD file. So a lossy format is, will allow certain information to be thrown away to make the image smaller. And the idea is that it can throw away image information that's not that important, and you can, still maintain reasonable quality. Most of the time this is acceptable, but you're always going to want to test to make sure that the final images look, good enough for whatever application you happen to be using. So here's an example. You can see how the effect of altering this information that's thrown away affects the quality of the JPEG. In this context, the process of throwing that information away is called compression. Compression is measured by the compression ratio, and as this ratio increases, the quality decreases. And so how much compression is acceptable, again, depends on your application. But you can see in this example, the original, there's quite a bit of information, or, quite a bit of quality there with the original image. We go to a 10:1 compression, and it starts to get a little bบgrainy, a little bit blocky, but it's still probably fine, and it might be, 1/10 the size of the original image. We get up to 45:1 compression, and it starts looking like, a 1980s video game, and that's probably not what what we want, unless that's the whole look that we're going for. Next format is the PNG format. Sometimes, not very often, this is called the PNG format. And this is the newest format that's widely used on the web. It was developed in the 1990s and is good at a number of things. First, it's quite good at displaying large areas of flat color. So contemporary designs that feature large blocks of color or smooth gradients, think of like Microsoft's interface with Windows 8, things like that. They usually work pretty well with PNG files. It's not great for photographs. It's not terrible, but it usually leads to a larger file size than the equivalent quality JPEG. Not always. It's, again, something you have to kind of play around with. So you just have to experiment to find out what's best. One of the best features of the PNG format is its ability to do complex transparency. This allows for smoother blending of images and other effects on a website. So that's kind of a big use for it. All right, so this one's going to be controversial. The GIF format is pronounced just like that, with a hard G. Now, some people believe that it should be a soft G and therefore pronounced like GIF, just like the brand of peanut butter. Since the acronym stands for Graphics Information Format, not the Giraffics Information Format, you can see my point. Still, just like Mac versus Windows, iPhone versus Android, and so many other issues in technology, this distinction is, leads to some rather heated discussions. I've been in these myself. Everybody has to have something to get worked up about, I guess. GIFs are not very efficient for photographs, as they usually produce pretty large files when you do use them for photographs, but they're great for images, again, with large areas of flat color. They offer simple transparency, nothing as advanced as what you can do with PNG. It's just kind of like the pixels there are not, there's no translucency kind of thing. So it's just pretty simple there. By far, the most common reason that GIFs are even around anymore, since they're a relatively old format, is the fact that they allow for simple animation. And I'm sure you've all seen plenty of animated GIFs around at this point in your wanderings on the web. They are everywhere these days, it seems. Yes, indeed. Fascinating. So we have all these different formats. How do you know which one to use? Well, if you generally want to minimize the file size without sacrificing much, if any, image quality. You'll first want to choose a format that matches the content of the image. Like I said, if it's a photograph, probably going to be a PNG, probably a JPEG. If it's large flat areas of color, maybe a PNG, maybe GIF. and then choose whatever seems to work best. It's best to try different options in Photoshop with the Save for Web option and just see what looks best. You have to experiment. There's no magic rule that always holds true, but you'll just kind of start to get a feel for how that actually works. A practical example of this topic is how Facebook handles images. When you upload an image to Facebook, they automatically compress the image. You're using their service essentially for free, so they want to make sure that the cost of storing your pictures is as low as possible. Now, this means minimizing the size of the file that they store and transmit when everyone just has to see your latest vacation pictures. However, you're not powerless in this. There are things that you can do to your photos before uploading them to Facebook that will dramatically improve the quality of the final version of the image. In eLearning, there is an article called "Why Facebook Photos Look So Bad" and the DIY solution to fix it. It's in this section, so please take a look at that article, and because it discusses these images or these issues in greater detail.